All right, I started the recording. Everyone ready? Didn't quite give you time. Uh, the recording started. The exam grade. I'll follow up on this thing today. Okay. The exam one, the midterm. Everybody appeared on the midterm, except if you didn't appear on the midterm without my acknowledgement, then not that much we can do about it. Okay. That's exam one. So exam one done. All right. So I'm gonna upload the grade sometimes today. Okay, that's my plan. But it would be night, so check the grade tomorrow. Okay. So give the exam. All right. I'm just trying to think. So the exam has two parts, right? The second part was due on Wednesday, right? Everybody got it, right? The second part, the take-home part, was due on Wednesday, right? The in-class was on Monday. Okay. All right, so I should be able to grade it by today. That's fine. So starting with our agenda for today's class, let's do a quick review. What happened so far? Some of you had like some excused absence, missed the class for whatever reason. So we are in chapter 13, right? And so far, we started some maths with chapter 13 based on some of the equation, the basic two equations that you have seen in the first class, force equation and weight equation. And the second class, last class, you have seen we explored it for three different axes, right? So summation of f, which would be, in three different direction, right? Fx, or you can write it like, m ax I ayj azk, right? The same thing is for summation of f as well, right? So that was the equation. I don't want to write any further because we spent like almost like 10-15 minutes on the theory, right? So those are the thing we did. Now in first class, the math that we did where we didn't have any friction force, if you remember that, right? Where a block was moving, I believe it was in a plane surface, right? It is moving from left to right, something like that, and there's no friction. So we did explore the normal force, the applied force, right? The weight of the block itself, and the resultant movement with the acceleration a. So that was our first class agenda. In the second class agenda, we had the block is still moving, right? But this time it was moving with an inclined angle, right? And not only that, in this example, we had this friction was there, right? It was no longer a smooth surface. So we had these forces like Fk. We had the weight, which has an angle like 30 or theta. That was a problem. We had the normal force. We had the tension or applied force F, right? And overall, we had acceleration A. So that was the problem for the second class or the Wednesday class. Those who missed the class, did you guys watch the video lecture? All of you? Okay, perfect. All right, so that was the agenda for second class. So for today's class, what is new, right? And it is this problem that you're seeing here. What you see here is spring. So it's kind of a similar problem what you've done in first two classes. In first class, you have the block is moving in a horizontal plane, which is here, right? In the second class, we have the friction force, which is here. We're going to count the friction force, right? Along with that, we have a extra thing came up, which is the spring. Okay, so we're going to count this spring force as well on this one. Okay, understand? So this problem, we're going to do it as like a, I would say, one-pay kind of way. Means you will try to solve it. Like I'm gonna, before you start to do that, I'm gonna draw the sketch, okay, for you with all the forces and give you some direction or hints, whatever you want to say, and I'll let you to solve it. Okay, how about that? Everybody watch the video lecture, right? The last class video lecture is so important. Okay, before I jump into doing anything, actually let me read through the problem and then start explaining a little bit more here. So we have a 25 kg block, okay, subjected to a force of 100 Newton. As you can see that force here, 100 Newton, right? Everybody? All right, that block is 25 kg. And then it says the spring, it's attached to the spring, which has a stiffness of 200 Newton per meter. And it is unstretched when the block is at A. Oh, by the way, you know all the materials, you're seeing it here, it's in bright space. You know that, right? So, I mean, maybe you would like to avoid writing everything. I mean, that way you will lose what I'm saying, like, the info that I'm trying to give you, okay? Everything is in red space. Not only that, even more, okay? I uploaded all the PowerPoints for all those chapters. So, like, if you're going to go bright space, you're going to see on the chapter 13, and I forgot if I'm going to create it chapter 13 separately or may not, doesn't matter. Like, the class materials, there are so many PowerPoints, right? So whatever I'm covering, like this time I'm covering this, right? So it would be like probably the second slides, right? Section wise, all the PowerPoints are there. I can show it to you at some point today as well. But for now, let's focus on the problem. Bottom line, why I'm saying that, don't waste your time writing everything. It's there, okay? All right, so what I was saying, like, kind of read through a whole problem here, except let me explain a little bit about the stiffness of the spring. You guys remember the spring force equation? I mean, probably from high school, right? Spring force is equal to Kx. K is the stiffness. And in this case, the stiffness was given as like, what's the value? 200 Newton per meter. What does it actually mean? I mean, to understand it like this way. So like if a spring you have, okay, you need to apply 200 Newton force to stretch it to 1 meter. Make sense? Okay, so that's what this thing means, stiffness. And obviously these values are given. Like, now, what else is given here? So they have it here that the spring initial position is 0.3 meter. And you got to understand, spring was unstretched when it was 0.3 meter, right? And then you have certain movement happen, right? You have this movement happen from here to here. This is S. Everybody see S here, right? There's the movement. And they give you the value of the S. So they said like this S is 0.4 meter. Okay? So the block, let's see if I can visualize the scenario here, was initially here attached with the spring down and it moved 0.6, sorry, 0.4. So initially no stretch and the spring was like 0.3 meter long, right? And here's another interesting thing that they gave you. They said, okay, this is 0.3, this is 0.4, right? And if this is like a right triangle, do you know what is this value? Hypotenuse, which is, you're going to do the Pythagorean, right? Which is 0.3 square plus 0.4 square is square root, which would be 0.5. You know that, right? Probably it's so common, like 3, 4, then the third thing will be 5, right? You know that. So you know that is 0.5, right? So why do you need that as 0.5? Why do you need that 0.5 value? Okay, to deal with this spring force. Why? Because the spring force equation is, don't worry, I'm going to write everything, whatever I'm saying, okay? I'm just trying to give you understand. So the spring force equation is what? K multiplied x. K value is given. X is what again? The spring displacement, right? So the spring is initially 0.3 meter. And then it gets stretched to what? 0.5 meter, right? We have to calculate that. It's not given, right, Joe? Directly? The 0.5 meter. So what is the displacement for the spring from 0.3 meter to 0.5 meter? What is the difference then? 0.2 meter. Does everybody understand that? 0.2 meter stretch. Did everybody understand? That's so important. Okay, so if you have a displacement of 0.2 meter, you know the K value. You're able to find the spring force, which should be K multiplied x, which should be 0.2, right? You got that idea? What I just said? Very good. So now that gives you the spring force. Tell me something. What would be the direction of the spring force? Along the hypotenuse, right? In the second position. Initially it was here, right? The block. And after some time, when it travels to 0.4 meter, then the spring is attached at an angle. Everybody got it? So the force will going to act on that angle, right? Where the spring is attached. So can you see the relationship from the last class problem? Like you see that when the block is here, you have this force, which is the applied force. Somebody must need to pull it, right? This is the applied force, 100 Newton. The spring is acting, resisting the pull, right? Along this direction. So that's the second force, right? Number one force, right, Kishin? Number two force. And one other force is here again. Because of the block itself, do you feel like it has a weight? So there is a W. So three force. What else? Is it normal force? This is a normal force, right? There is a reaction coming from the floor. So that is acting up. Is there anything else? We are in not statics class, we are in dynamics class. Things are moving, right? So it's a movement. That means there is a kinetic friction as well. Why I'm saying that? This block is moving from here to here. It's movement. It's on movement, right? There is a friction, kinetic friction, acting oppositely, right? So see how many forces there? The applied force, the kinetic friction force, four forces, right? The applied force, the kinetic friction force, the spring force, the weight, the normal force. So many forces there, right? And not only that, the story didn't finish it here. See what happened when it is moving, right? It is moving to a certain acceleration, right? Makes sense? Resultant to all four forces that we just said. Do you guys agree with me on that? So that's the fifth component. Okay. So you are asked to find here. That's what I said here. Find the acceleration A, the resultant acceleration. Okay. Now what I'm gonna do? Everybody understand the problem? Everybody understand the problem, right? Ready for the work at the problem means I'm gonna draw the sketch. Okay, and I'm gonna let you deal with this one. Okay, so all I'm saying here, okay, you have this block, and this preview thing, what I had from last class, I'll just simply take it out. I don't want to confuse you with anything. So this is the block that I would like to draw myself again. Okay, you see here, everybody see here. Okay, and I'm gonna draw it again by myself. Okay. Okay, would be zooming. It's a smooth surface. I'm sorry. they makes the problem much easier. Reducing one force. Yeah, in second class we did the friction force, right? But in this, today we are just assuming there is no friction. Okay, that makes your life much easier because for friction they should have give you like the mu k. Everybody remember what is mu k? What is mu k? It's coefficient of friction, but kinetic. So they call that kinetic coefficient of friction, right? If they could have given you that value, then you could have solved it, right? I mean, if you want to make it more interesting, I can give you that value. That problem would be completely different. Another force is going to come up, but we're not going to do that. We'll make it easier. So, okay, maybe you can do it as a homework, right? Just apply that extra force and try to do it at home. Anyway, so we have this block here. This block does have a weight m. So let's start with the givens, right? What are the givens here? This m is 25 kg, right? All right, so they have so it does have an applied force F. So this F is 100 Newton. Okay, and it does have a weight, okay, W, acting downward, right? This weight equal, this not given directly. That's the equation for weight mg. I'm not going to write it at given. Rather, I'm going to write the g because g is known, right? 9.81 meter per second square. You're probably solving the whole problem already, or you find the weight. You find the weight. Yeah, I assumed your probably movement. All right. So what else is there? You do have the W. Okay. Sorry, and you do have the N, the normal force, which is not given. I don't want to write that, right? But you can find it, right? Gavin, you remember in last class we found the normal force when you do the summation of Fy, right? Would be doing it the same. And there is this force, right? This is spring force. Do you know the angle for the spring force? We don't, or do you? Do we? We do. We have a means to find it. How? Because remember, this is like what? 4, this is 3, this is 5. Can I write that? It was like 0.4, 0.3, and 0.5, right? It's the same thing. All right. So, okay, by the way, you need to know the stretch and everything. That this is spring force. I can write Fs. You guys okay with me on that? All right. So that's the free body diagram. So that is your free body diagram showing all the external force. So that's your free body diagram. I want all of you to do the free body diagram in homework in an exam. Okay, make sure you do that. I have started noticing some students just don't do that. Please do that. I probably give you points, but I'm putting the thing like, yeah, do the free body diagram. Do the free body diagram. I need the sketch. Or probably I was putting like I put the sketch somewhere. Anyway, the free body diagram. Okay. So far, everybody's good. What? Okay. So there's more. Like this as well was given as like 0.4 meter, and spring initial displacement, say like x0. To understand that, I gotta probably draw this sketch again. You know what sketch? Like this thing. Okay, to understand it, two things you gotta do. There's the force diagram. Okay, and let me try to draw the sketch. Right. So like you have the two blocks in two different places. So like you have this block initially here. You have this block finally come to here, right? I'm putting a dot for the second block, and then say like you have this spring starting from here, and say like you have this stretch of the spring happen here, right? And say like this distance, say like you know this distance, right? What is this distance again? Anyone? No one?
0.3.
Thank you. I'm just trying to see. I knew that. Trying to see how much engaged you are. So this one, what is this distance again?
0.4.
0.4. Thank you. And this is a right triangle, right? So that means we can do Pythagorean, right? We know the distance though. I already talked about it. What is that? 0.5. And how did you find it? This was from square root of 0.3 square plus 0.4 square, in case if anyone is wondering. Okay. All right. I hope this is not going to confuse you. Let me try to make it as much as possible. Okay. So now it should be all right. So far, everybody's good? All right. So now come back to original thing. So x0, you can name this thing is x0. You can name this thing is x1. Okay. So x0 is 0.3 meter. Okay. And this x1 is, that's technically not given. So I don't want to write it. Okay. I'm going to do it in the calculation portion. All right. So then the final thing is obviously find what we're trying to find. We are actually trying to find, you see, when this block is moving from left to right, what is happening? There is the acceleration for that block, right? That A is the acceleration. We're trying to find the acceleration of the block, right? Of block A. So that's what we're trying to find, right? Can you do that? Maybe. Yes. All right. So, okay, we got to do the X and Y two different direction force balance. Now, for that, there's the thing that you got to do. You got to put the X and Y coordinate. Okay, just like in last class. Whoever in the last class, whoever watched the video lecture, you've seen we have done this thing, right? That was an inclined plane. We don't have an inclined plane here. We have a flat X and Y, vertical and horizontal. So that's even make our life much simpler. To solve this problem, right? Just like last class, We're going to approach it that similar way, very similar way, okay? But before we do any of these things, let's explore this FS, the spring force, right? Let's do that. So spring force, that's the last thing you want to do to find the acceleration, by the way. So the spring force would be, and don't worry, I'm gonna leave something for you to do, okay? As I said, work kind of thing. But if I'm gonna leave it to you like from scratch, then some of you might be able to do that, some of you will be all over the places. From experience, I know. So that's why I'm trying to give you as much direction as possible. So the spring force, Fs, can be written as, what is that equation again? Kx, right? All right, so this Kx here, this x spring displacement, I can write it in spring displacement x. I can write it this way. It is x1 minus x0. How many of you agree with me on that? Everyone? All right. So then we do have both values. I can write that value as like what, like 0.5 minus 0.3, I guess, which would be 0.2. Sorry, I'm doing it on the right. I'm trying to capture everything in a shorter place as much as possible, so you can see the whole thing. You got my intention. Otherwise, I could have write it down, right? So this Fs equal to K multiplied X, and here obviously you have this 200 Newton per meter multiplied this 0.2 meter, which would be giving the value of what? Like, is it like 40? For some reason, I don't, I don't have it solved with me. I don't have the notes, but you might have to help me with the values. Is it 40, everyone? Yeah, it is 40 Newton. That N looks a little weird. This is N, what I was trying to write. This N is the Newton, right? This is your Fs. Now, you see, at this point, your focus is done, officially done. Your focus is officially done from here. You don't need that much from here anymore. Okay, this is done. Okay, whatever you wanted to explore from this is done. This Fs. Now you are only focused with the free body diagram and the x and y coordinates. Based on the last class knowledge, can you do based on the last class knowledge, can you do this force balance in x and y direction? Whatever we did in the last class. What is our goal again? To find the value of the A. We had the A in last class, remember? On the right side in x direction. I mean, the block, is in flat surface, right? It is moving on flat surface. It's not moving on upward. So in y direction, there is no acceleration, right? Is that? No, there's not. There's not. Okay, this problem even is much simpler. You may not even have to explore the y direction one because there is no friction force. If I could give you the friction force, then you should have explored the y direction to find the value of what again? The normal force, right? You're going to do the summation of Fy to find the normal force, which we don't have to do it in this problem because it's a smooth surface, right? There's no friction coefficient. Everyone understand? So if you're going to do summation of Fx, that is going to give you the value of the A acceleration. Okay? This point, I don't want to give you any further. I mean, I'd like you to explore. You've got the value of A already. What is the value? 2.61. Is that the value everybody found? Who else? Alicia, right? Alicia found 2.61. Anybody else found 2.61? So, number 2.
I was asking, why is x0 0.3 meters? Is that an x value?
That's the spring length is given.
Why are we labeling it as x?
So, from here to here is the spring, and that's value. You agree with me with this 0.3?
Yeah.
All right. Now coming here with the labeling, right? So I label this thing the way I want it. Your choice, okay. You do. But the way there's intention behind that. Like, always the spring force is Kx. X I want to keep, right? So you understand, even though it's going in y direction, I know it confuses you, right? It's going in y direction. Why I'm putting the x0? I now got it, like why it's saying that. Yeah. And it's just because the spring constant. Yeah, Alicia, why don't you solve this thing, like putting this value of friction coefficient at 0.3 and see if you can find the value of acceleration in that case. Okay, that means it's no longer a smooth surface. It does have some friction. Okay. Gavin, you said you solved it, and Gavin said, why don't you extend this problem, solve it for, as I said, like spring coefficient value as like 0.3, friction coefficient value as 0.3, okay? Then you're gonna do summation of y, just like in last class. This you understand? Yeah. So if you are done in the first part, find the acceleration, second part, find the same acceleration, but this time you have the friction force when the mu k value is 0.3. Yeah. Okay. Logan, you're done also? Once you get this a value, 2 point something, whatever they're saying, and then find that value. Okay. Did you find that a value? You need some help with it. Okay. Okay, Joe, you found it? You found the a value already? Yeah. Brad, you found the a value already? All right. So I'm making the problem even much interesting. So I'm putting this way. So that part A, when the mu k is 0. You understand? It's smooth surface, right? It's a smooth surface. Don't worry, I'm going to solve everything, okay? If you are struggling with anything, I'll solve everything. You have the opportunity to take the notes and everything. And part B, find the acceleration again of the block A again when this would be a different A value, right? Mu k 0.3. Means you have a friction force. No longer is this friction. You got it? So two different scenarios. Solve A first, which you are doing, right? Okay. So solution, part A, let me help you solve that. So in part A, I probably need the free body diagram here. So let me copy the same thing, copy and paste it here again. All right, we are trying to solve the part A, right? So how going to do that? More than 50% students finished already. But if you need some boost or help, you want to do it this way, like, summation of fx, just like in last class, okay? Which is in what direction? Horizontal direction is equal ma. What is m? M is written here. M is the block, right? We're trying to find the value of the A. So in the left side, you have this Fs, right? That force, and you can do that. You can actually find, there's different way you can do that. You can actually find the value of the theta. That is one way of dealing with that. Or the other easiest way, that the way I teach you guys in statics class, if you remember. So that would be 4 divided by 5. You guys remember that? Instead of going with the theta. Tell me, remember in statics class I teach that instead of exploring the theta, if think this way. So you have this Fs, the Fs, right? It is an angle. Okay, so this Fs is the maxima. It does have two components, an x component and y component. Your common sense tells you like the x and y component will be smaller than the resultant force, right? So if you know the resultant force is like 5, the distance 5, the x direction would be definitely 4 and the y direction would be definitely 3. Does it make sense? So yeah, so does you understand that, right? What I'm saying? Very important thing. Say like this Fs, right? That is at an angle, right? So instead of finding that angle and finding like this Fs sine theta and Fs cos theta, that is one way, you know that, right? Instead of doing that, easiest way would be, say this Fs is like if you're considering a right triangle, is the hypotenuse of 5, right? And the height is what? 3, and the base is 4, right? So base is x direction. You understand that? So if I'm gonna do like this, if I know the value of the Fs multiplied by 4 divided by 5. Does it make sense? So the fraction, that's the way you can avoid the theta. Brett, you understand this 3, 4, 5 principle? And I did teach it in the statics class, if you remember from the statics class, and I hope you probably learn it from different class as well, right? So I'm gonna simply take out this theta. Okay, that way you understand it, right, Joe? So that way you will not going to have any confusion. Okay, and later on maybe wondering like, okay, where is this theta gone? And there won't be any confusion. Okay, so you have this fs, this x component, and this is acting in negative x direction. So there is a negative, obviously. You have this plus f, or applied force 100. Okay, and that's it, right? Is there any more? So then it's equal to m multiplied a. Now it's time to plug the values. So if this 40 Newton multiplied 4 divided by 5, right? And then what is the f again, Gavin? Is it 100? What is the m again? Is it 25 kg? And what is this a? That's what you're trying to find, right? So I hope this is the math that you did, right? There's the negative before that, right? What is the value of a? So a should be equal. Let me put everything in a math form. So this one would be 8. So minus 8 multiplied 4 is 32, right? Plus 100. And the whole thing would be what? Like meter per second square. And then what is the value you got, Alyssa? 2.614. Is that the calculation the same way you did?
I did it slightly different. I used the cosine of the angle.
Oh, you did the theta thing, but what about like, okay, I can kind of tell you like 68 divided by 25, is it like 2.614?
Yeah.
Okay, so then I'm doing it right. So that is part A. How many of you have any question? Does anyone have any question? You don't understand? Part B you guys have done also? What is part B?
I have 0.569 to the left, so it's negative.
Negative? Okay, seems like that's correct. So what's the value? Negative?
Negative 0.569.
0.5. What does it mean really?
So it's 5.569 to the left.
It's going the other way. It's going the other way. So that is the impractical problem. So that means the friction coefficient that I gave, that needs to change.
Yeah, because otherwise it would like.
Oh, so what that value needs to be to make it positive? I mean, you have done the math. I didn't. You got a comment.
Plug it back.
It's smaller,
Yeah, it
much
has to be
smaller.
Smaller, yeah.
So go with like 0.2. See if it changes. Go with 0.2. See if the value getting.
So does that mean the 0.3? That means the spring's pulling the block back. Is that what
Yeah, that does mean this way. I mean, and 0.3 means it's actually not, the fast is not even moving. It's not a dynamic problem. Okay. Yeah, and it is not practical. You understand? They'll know what I'm saying. So the 0.3 value is bothering me. So if you're going to use quantity, the part is done. That's fine and dandy. Okay. This problem is done. We are not doing advanced stuff. Means what if we are using a friction coefficient? If fourth force is going to come, right? The kinetic friction force, and then the A value is going to change, and they found the negative A value. We're talking about that. Okay. Does 0.2 helps?
Yeah, 0.2.
Okay. So if you are doing the second part, can you do? I mean, that's my apology. Can you do one thing, please? Change this to 0.2. Okay. You understand what I'm saying? Part B, mu k, the coefficient friction. Okay. Let me do that. So part B, coefficient friction. So when mu k is 0.2, do I need to put a unit with mu k? No, because it's a coefficient, right? Unitless. All right. So that find what we're trying to do. Find the same acceleration a. Now can I do one thing? Okay, let me put this scratch. Can I use the same free body diagram? Yes, I do, but is it complete? Do I need to put something? I gotta put the friction force, right, Brad? So the friction force would be here somewhere. Friction force could be FF. That's the way you wanna say, and it is mu k n. Everyone know that, right? So that's the component came here. And now obviously what you did the summation of Fy, right? Everybody? And then you find the value of the n, the normal force, right, Joe? And then once you have the value of the n, you did the summation of Fx, okay? And then one extra parameter come, and then the n will gonna get resolved for this F or friction force, right? Logan, you with me?
Yep.
Okay, perfect. All right, so I was saying like, okay, you got to do two things, right? Summation of Fy, and you know the block is not moving in upward direction, so it should be 0. And you do have this weight equal normal force. I mean, I know you might be getting confused. So minus W plus, and there's one more component, right? This Fs component as well. So that would be negative as well. So Fs multiplied by 3 divided by 5. So those who solve this summation of Fy, Alyssa and Christian, everybody put these three things. Okay. Everybody put these three things, right? And was able to find the value of the n. Do you know you got it? Why I had this equation here? You understand why I have this equation here, right? This I'm doing it. You understand why I'm doing it, right? In the first place. Part B, we have the friction force. So we must need to find the normal force somehow. Because this normal force, we're going to use it here to find the friction force. Does you understand the tie? You must need to find the normal force. So you can plug it here to find the friction force, okay? What is the value you found, Christian? A value?
For
Yeah,
normal
it will be
force?
slightly different.
Normal force, what is the normal force you found?
245.25.
Huh?
245.25.
Let's say you get the same value, 245?
For,
Normal?
yes.
Okay. All right. So mg plus the normal force is unknown minus is the Fs is known, right? Fs is 40. 3 by 5 equal to 0. So this normal force can be written as mg plus 40 divided by 3, 5 Newton. M is, what is the M again here? 25, is it 25? 9.81 meter per second square. All right, I could have avoided that. So 40 multiplied 3, I could have get the final value. Okay, so then once you do the calculation, what is the value, Christian, you found?
245.25.
Is the math the way I wrote, the same way you wrote?
Yes.
All right, so then
I got 269.25.
You got 269.
I got 269 too.
Alyssa, is it,
You forgot to add the 40 times 3/5.
Well, that's on the next spot.
You gave him the answer to the W.
Oh.
Yeah, you're giving W.
No, you are.
I am?
He's giving normal.
oh,
Yes.
Oh.
Alyssa, is that the case?
Normal, I have 265.
So okay, I gotta pitch in. It's all right, but you guys have the technique correct. So that is what I'm wondering. So you have this 25 multiplied 9.81 plus 24, 269.25. Alyssa, check your math. It should be 269.25. It could be a little confusing. N and N both sides. N is the force. Remember that. The N is the Newton. Now there won't be any confusion. Well, what happened?
I think it's only because I'm using the theta and not the field.
Other theta?
Yeah.
Is there anything wrong with theta?
Well, it's not
But-
that. It's just
But you got the first one correctly, 2.6. Does everyone get 2.614?
I get 2.72.
Yeah, I got
it's gonna be It's gonna be slightly off though to the cosine. 'Cause it's not exactly the same. So it depends. It's only 0.1.
But here it is like
This one's different because it's such a larger number. But I think
I wonder if the theta is.
I think it's only because of that.
It was let me calculate theta with you. So this is your theta, right?
Yeah,
So how
it should
do
be
you-
30. because it's a perfect right triangle. So it's 30 and 60.
So cos inverse. Sine inverse 0.3 divided by 0.5. See what happens. Sine inverse 0.3 divided by 0.5. That's what the problem.
Okay. Yeah.
So you change the theta value. Okay, I think those who calculated it based on theta, there could be an issue with that. Like I had obviously that chat with Alisa. Did you calculate it based on theta or you did?
No, I did this, I just forgot to do.
Oh, okay.
Yeah.
For your case, so you got it resolved, Alicia. Your case will be get resolved as well. What about you? Did you not resolve? You guys have any question with me so far? You understand?
Yeah.
You see the approach that we're doing. So this is not complete yet. You know that, right? Because you're gonna do summation of fx. What if you try that? You're gonna do summation of fx. You would like to start to put all the forces in x direction, and your ultimate goal is what, Brett? To find the value of the a, right? Yes, Joe.
This seems correct.
You find the value of the a already? I didn't calculate the first one. I don't know. Alright. Hey, Gavin, what's the a value found for the case B?
0.25
For case B.
Yeah.
W.
Logan, you found it already, right? What is the a value found for case B?
About to get it in 2 seconds.
I'll do it as well. All right, I'm doing it while they're working.
I got that too.
Huh?
0.566.
Joe is correct. All right. I hope both of you correct. Let me do it as well. So confirm it. Okay. Okay. Summation of fx equal to 0. All right. So then we have what? In x direction, we have this f, the applied force, minus ff. We have this fs, right? We have this fs that be negative as well. So fs multiplied by 4 divided by 5, right? Equal to 0. Did I miss anything? No, right? In the right side, I did miss something. I should have write ma because there is a movement, right? All right. So then let me try to find m multiplied a here, and this f, I'm going to rewrite the same thing. Fs multiplied 4 divided by 5, and then I'll start to plug all the values. So 100 Newton minus 0.2 multiplied by n, right? I don't know, maybe I should be writing it this way. That way there won't be any confusion. All right. So 0.2 multiplied by 269.25 Newton minus, what is my fs again? Is it 40? 4 divided by 5, right? So these three components, if you're going to do the math, and you have this 25 kg here multiplied a, if you're going to do the math, then a value should be equal, so you should have like 25 here, 100 minus, let me do some math here, 0.2, so you can verify it with me, 269.25, so you have this 53.85, and minus, you have this 40 multiplied 4 divided by 5, you have this 32 here. So the whole thing would be in meter per second square. So then you want to do it like 100 minus 53.85 minus 32 divided by 25. So you have 0.566 meter per second square. Yep. Thank you, guys. Good one. All right. See you on Monday. And as I said, by tomorrow I should be able to finish the grading. I'm gonna take it at home. Okay. All right.
Does it work with the?
Yeah.
Yeah.
I just
Really?
assumed it
Wait,
was
that's the
30
2 seat
degrees.
out.
Yeah.
Oh, yeah.
Okay.
I was actually.
So I'm keeping it here. You know, you see some more time.
I don't know what I was.
And as well as I'll stop the recording now. The recording I'm gonna upload it.
I was trying to do that.
Yes.
I was getting some.
Yeah, no, I don't know why I thought it was gonna be exact.
So the midterm was in Monday. The exam one. I said it exam one because there was a three exam.
Friday, the week of last week was, first part of the exam.
You did the exam here for this class?
Yeah, in person, it was Friday, last Friday.
Are you sure?
He was like second part in person, it's a take home quiz.
What was the exam on Friday?
It was three questions.
Elisa, was the exam was on Friday?
Yeah.
Oh, I'm sorry, I don't know.
Friday.
That was pretty bad.
Take home was.
Somebody, yeah, no, I understand. Somebody missed the exam.
Oh, no, AP was here. But I was here for the exam on Friday.
Maybe.
And
No,
I didn't know that.
But you did miss so many classes, even on the other section, like,
Yeah, it's good.
programming.
I went home because I got stuff going up. I was checking everything online. I downloaded the videos and everything.
Yeah, you gotta come to class. You
Not
gotta
yet.
let me know what is going on. Alright, there's exam, okay, you know that, right?
What was it?
No, there will be exam on that class, next class, which is on Monday.
Yeah, it was just, was it 0.2 or 0.3? Because I know.
0.2.
Okay, that's probably what I got wrong, because I was multiplying it by 0.3.
It looks a little small. I suggest you to sit on the fast bench. You might have some issue. Sometimes I have it bigger, sometimes I have it smaller. I know, but this time, when I'm trying to put it on other sometimes.